In lesson 6, we're going to look at applications with rational equations. So for this first example, we have a scenario where we have one number is twice another number, and the sum of their reciprocals is 2. We want to find the numbers. So the key word here is that we have reciprocals involved, and whenever you see the word reciprocal, it just means to flip the fraction. So it just means flip the fraction. So basically, if I had the number 3/4, its reciprocal would be 4/3. You just flip it. So those two numbers are reciprocals of each other. So if I have one number is twice another number, so let's start and let's say let x equal one number. And then we have another number that's 2 times this first number. So we also have 2x equals, let's just say, the second number. So one of the numbers is x, so this other number is x, and the one number is 2 times that. So we have x and 2x. We want the sum, so we're going to add their reciprocals. So the reciprocal of x, so you really think of this as x over 1, the reciprocal of that is going to be 1 over x. The reciprocal of 2x, if you think of 2x as 2x over 1, is going to be 1 over 2x. So the sum of their reciprocals, so add, is 2. Then we need to find the numbers. So basically I took my x and my 2x, I wrote them as reciprocals, I added them, and then I set it equal to 2. So now what you're going to do is you're going to use one of the methods that we learned in the last lesson, which in this case it's a fraction plus a fraction equal to a number. So I got to look for the LCD. The LCD here would be 2x. So that means I'm going to multiply everything by 2x, every single piece. We can cancel x's here, so we have 2. We can cancel the 2x's, so we have 1. And then 2 times 2x is going to be 4x, and then we just solve it. So we have 2 plus 1 gives me 3 equals 4x. We're going to divide everything by 4, so we get 3/4 equals x. So that's actually going to be the first number. So the one number will be 3/4, and then the second number is 2 times 3/4. And if you remember, whenever we multiply fractions, you think of it as 2 over 1. You can cancel these. 2 goes into 4 2 times. So I have 3/2 as the second number, because remember, you multiply across the top, multiply across the bottom. So 3/4 and 3/2 are the two numbers. So let's look at one more equation. And just so you know too, I did check this before I move on. I did check to make sure that this actually worked, and it does. It wouldn't create 0 in the denominator, so that's why I can use it. And then once I find that, I go ahead and I plug in to figure out the second one. So we have one other application problem, and this one is using a formula that you learned probably back in algebra, which talks about rate. So the formula that you have to know for this scenario is that we have the distance equals rate times time. So distance equals rate times time. So looking at this formula, or looking at this problem here, we have two families, and two families here are from the same neighborhood, and they're planning a ski trip. So the first family is driving a newer vehicle and makes the 455-mile trip at a speed of 5 miles per hour faster than the second family. So the distance here for both families, they're both going 455 miles because they're going on this ski trip. So we're going to fill out this chart to kind of help us organize this problem, because otherwise it's kind of a difficult problem. So both families are traveling 455 miles. The rate, which is really the speed, is going to be in miles per hour. So we have one family is, so the first family is traveling 5 miles per hour faster than the second family. We don't know how fast they're going, so that's going to be our variable. So we're going to let x equal the speed of, we're going to say of the second family, because the first family is going 5 miles per hour faster. So the speed of the second family. So the second family is going to be x miles per hour. And the first family is going 5 miles per hour faster. So it's going to be the rate of the first family plus 5 miles per hour faster. So x plus 5 miles per hour would represent the speed of the first family. And then the next thing here is the time. So it says that we have the second family takes a half hour longer to make the trip. So the second family is going to take a half an hour longer, and we're trying to figure out what are the speeds of the two families. So we want to basically solve this for x. So there's a couple ways that we can look at time. We know that the second family, so I'm just going to write this down here. So second family is going to take 1/2 an hour plus the first family's time to make the trip. And then for this part for time, I'm actually going to use this d equals the rate times the time formula. And if you rewrite this so that it's what time is, so basically solve it for t, so divide everything by r, you'll see that time is really the distance divided by the rate. So time here, I have distance is going to be 455 miles divided by x plus 5. So x plus 5 miles per hour means that the time is going to be 455 divided by x plus 5 hours. So that's how long it's going to take the first family. And then the second family is going to be 455 divided by their speed. That's how many hours. So that last sentence, or second to last sentence, says that the second family takes a half an hour longer. So I was able to make this equation up. So basically I can use this relationship to help me solve this problem if I take and I plug these two values in. So the second family's time equals a half an hour plus the first family's time. So I'm going to go ahead, I'm going to plug those in. So the first family, so let's just equals 1/2 plus the first family, so 455 over x plus 5. And the second family's time is going to go in over here, so 455 over x. So now, once you get the setup, then it's just solving, but the setup is what makes this problem difficult. That's why we have this chart to kind of help us basically take out the important information and then come up with this relationship of how can we actually use these algebraic expressions. And again, this formula is something that you've seen a while ago. So whenever it talks about distance and speed and time, this is something that you want to be thinking of. So I want to go ahead and solve this. Again, I can't use cross multiplication because I have a fraction equal to a fraction plus a fraction. So I'm going to have to figure out the LCD. And if you look, the smallest combination of all of these is going to be the LCD. So 2 times x plus 5. So I'm going to take and multiply every single piece by 2 times x plus 5. So times 2x times x plus 5 and 2x times x plus 5. So then we can cancel anything that we have. So here we have 455 times 2x plus 5 equals, my 2's cancel here, x times x plus 5. I'm actually doing a little bit more work than I have to just to make sure that you're seeing where I'm getting these numbers from. Like I could have just gone ahead and have done the distribution, but I'm just going to wait on that. So I cancel out the x plus 5's. I have Again, 455 plus 2 or times 2x. So now I can go ahead and actually combine things here. So I have 455 times 2x plus 10. And then I have, so basically I just distributed this 2. So if you wanted to, you could have multiplied the 455 times 2, and then we'll distribute that number, or distribute the 2 first, and then my next step will be to distribute the 455. I'm going to go ahead and distribute this, so I have x squared plus 5x. And then at the end here, 455 times 2x is going to be 9 10x. So now I'm going to go ahead and distribute this. So I'm going to have 9 10x plus 4,550 when I multiply that by 10 equals x squared plus 5x plus 9 10x. So hopefully you're thinking, okay, I need to factor this to be able to solve because there's an x squared. So that means I need to get 0 on one side. So I'm going to go ahead and bring this 9 10x over. And if you look, before I combine in my like terms over here, I'm just going to go ahead and subtract those 9 10s because I know they're going to cancel. And I'm going to bring this 4,550 over. So these are going to cancel. So I'm going to have 0 equals x squared plus 5x minus 4,550. And now we need to think of factoring. So if these numbers are too difficult to find factors of, remember you can always use completing the square or quadratic formula. You can always use one of those techniques. I'm going to go ahead and factor though. So I have x, I'm going to have opposite signs because I'm multiplying to a negative. And since this ends in a 0, that means I can think of some kind of number. I could probably divide it by something that has a 5 in it. So 65 is actually going to go into 4550. So 65 and 70 are going to work. So I have each piece of these now I can set equal to 0. So we get x equals negative 70 and x equals 65. Now remember you want to check these. And both of them will check. The only issue is we're talking about speed. Remember, x represents speed. So we're going to actually reject this because we don't want to have a negative speed. So then that means we're going to keep this 65. And this is going to represent the second family's speed. So let me just write like a little blurb off to the side here. So the second family's speed is 65 miles per hour. And then to figure out the first family, so the second family is 65, the first family is going to be 65 plus 5. So then, and the first family's is 70 miles per hour. So then that would be it for that problem.